We are going to start on this note sheet and then we'll move into the book. So we're going to learn how to solve absolute value equations. We briefly touched on it already, but let's go through this. So step one, we need to isolate the absolute value expression. So that means those two absolute value bars, we need to isolate that, get it all alone. Step two is drop the absolute value bars. And we're going to write two equations by setting the inside expression, what we have left after we drop the bars, equal to the positive and negative number. So what that means is we need two equations, so we're going to have two answers. Step three, solve for the variable, which usually is going to be x in both equations. If the absolute value expression after being isolated is equal to a negative number, there is no solution. Absolute value is the distance away from 0 or from 2. So remember, absolute value cannot be negative. Our answer can be a negative number, but we cannot be set up equal to a negative. So let's go through some examples here. Number 1. The absolute value of 2x minus 1 equals 7. So my absolute value bars are currently all alone by themselves. So step 1 is complete. Step 2 says drop the absolute value bars and write two equations by setting the inside. So 2x minus 1 up equal to this positive 7. So the first one, we just dropped the bars. The second one, we dropped the absolute value bars, but instead of having a positive 7 this time, we set it equal to a negative 7. Now we're going to solve these two equations like we've been doing since the beginning of the trimester. So we want this 2x alone, so we're going to add 1. And if you're a student that likes to draw the line down on your equal sign to keep your two sides separate, you can still do that. Divide by 2, because that's the opposite of multiplying. And x equals 4 is my first answer. Now my second equation is going to give me a different answer, but we solve the equation the exact same way. So I need to get rid of this minus 1. So the opposite, we're going to add 1 to both sides. Negative 7 plus 1 is negative 6. Divide both sides by 2. And my second answer is x equals negative 3. Example 2. The absolute value of x minus 3 equals negative 5. So this is asking which two x values are negative 5 units away from 3. My absolute value bars or expression is already isolated. It's already by itself. And this is set up equal to a negative number. So this is no solution. I cannot be negative 5 units away. Distance cannot be negative. Example 3. Let's move into examples that we need to isolate first, that we need to get alone first. So if I highlight my absolute value expression, it's this x plus 2, which is inside my bars. So currently, it's not completely alone. If you're looking, you see that there's a 3 out in front. 3 is really close to those absolute value bars, so that means they're being multiplied. So the opposite of multiply is to divide by 3, and that cancels. Divide by 3. So this is step 1, isolating your absolute value expression. So what we're left with is the absolute value of x plus 2 equals 21 divided by 3 is 7. So now I need to do step 2, where we drop the bars, and then we drop the bars and set it equal to a -7. So notice I didn't go back up to the beginning and make this a 21 and a -21. So this equation is basically gone after I isolate, and this is my new equation, my new absolute value expression, and this is what I use to make my two different equations. So don't go back up to the beginning part. Okay? Now we need to get rid of this plus 2, so the opposite is to subtract 2. X equals 7 minus 2 gives us 5. I'm going to solve this equation the same way. Subtract 2, subtract 2. This time it's a -7 minus 2, and that gives us -9. So again, we need to have two equations, which gives us two final answers. Example 4. The absolute value of x minus 3, and then subtract 6 equals -2. So if I highlight my absolute value expression, it's the absolute value of x minus 3. So what I need to do first is get rid of what? Get rid of that -6. How do you do that? Add 6, add 6. So I have x minus 3 equals -2 plus 6 gives us 4. So now moving forward, this is my absolute value equation that I need to use for step 2 and step 3. So step 2, we drop the absolute value bars in order to make our two equations. One is set up equal to the +4, and one is set equal to a -4. There's no absolute value bars here. Make sure you're dropping them. That's why I can have one equation positive and one equation negative. And then we just need to solve them both. You can do that. Add 3, add 3. X equals 7. That's my first answer. Add 3, add 3. X equals -1. Okay, -1. Now, let's switch gears here and let's open our books. And we're going to open our books to page 51. 51. Okay. On the bottom of page 51, you're going to see example A. And example A is just like an example that we went through on our note sheet. Okay, but I'm actually going to go above example A, and we are going to look at question 11 here, 11C and 11D, and let's solve these two. I have the absolute value of x plus 2, and that's alone on one side, or that's isolated, so I don't have to do step 1 from my note sheet, so I can skip that. And let's jump straight to step 2. So drop your bars. There's my first equation. Drop and make it a negative. So pause the video, and I want you to try to solve both of these. Subtract 2, x equals 5. Subtract 2, x equals negative 9. So yes, you might be thinking this is double the work because I have 2 equations to solve, but remember we solve them the exact same way. Notice I subtracted 2 on both equations. Question D. My absolute value bars are isolated. They're on one side all alone. There's nothing in front of them. There's nothing after them besides the equal sign. So immediately drop your 2 bars. And I want you to pause this video and try these questions. You can do it. Add 1. 2x equals 6. Divide by 2. We get x equals 3. Add 1. 2x equals negative 4. Divide both sides by 2. This cancels. X equals negative 2. All right, turn your page to 52. And notice, I want you to work on the try these A. So I want you to solve all of these questions. You can do it. Pause the video and take the time to do that. All of these equations or absolute value equations are isolated. So immediately we're just going to drop the bars and we're going to solve. All right, I'm going to run through all the answers. Maybe I'll post my work later. So, letter A, x equals 4 and x equals 6. X equals negative 7. X equals negative 3. So check your answers, check your work. X equals negative 7. X equals 4. And let's walk through this one. So let's add 4 to both sides. 3x equals 12. Divide by 3. X equals 4 is the first part of our answer. 3x equals negative 4. We're going to get a fraction. Divide by 3. X equals negative 4 thirds. Or you could change that to a mixed number. X equals negative 1 and 1/3. Okay, whatever you prefer. You can walk yourself through example B, read step 1, step 2, etc. And it's similar to a question that we did on our note sheet. And then let's move on to the try these B. Solve each absolute value equation. So all 4 of these, you have to isolate your absolute value expression first. So get x minus 1 alone. Get the absolute value of x plus 4, absolute value of x plus 6, and just the absolute value of x. So all of those need to be isolated first before we set up our 2 equations. So divide both sides by 3. X minus 1 equals 4. Now from here, we set up our 2 equations and we solve. So my first equation would be x minus 1 equals 4. The second one is x minus 1 equals negative 4. So continue to solve that. You can do it. Pause if you need to. X equals 5. X equals negative 3. Letter B, this one tricks students because they like to overthink it or overcomplicate it. We need the absolute value of x by itself, so let's add 14. Add 14. And I get the absolute value of x equals 20, and I can just look at this and know my 2 answers. Right? There's absolutely no solving to do here. What 2 numbers are 20 units away from 0? Or drop the bars. That's my first answer. Drop the bars and make it a negative. And we're done because x is already by itself. Question C. Pause the video, please. Try this on your own. You can do it. My first step is to isolate what I highlighted, which is the absolute value of x plus 4. So I need to subtract 5 from both sides. And we're left with the absolute value of x plus 4 equals 3. Now we set up our 2 equations. One's a positive 3, one's a negative 3. One thing that I forgot to point out or mention is hopefully you're noticing that x plus 4 and x plus 4 stays the same. Up here, x minus 1, it stayed the same. Okay, I don't switch those signs. I only switch the 3 to a negative 3. Subtract 4. X equals negative 1. Subtract 4. X equals negative 7. Those are my 2 answers. All right, question D. Let's get rid of this 7 first. So let's add 7 to both sides. So I have 3, the absolute value of x plus 6 equals 27. Now what do? Pause the video and finish it. I think you know. It needs to get this all by itself. So divide by 3. Those cancel, and we get x plus 6 equals 9. So drop your bars. One's a positive 9. Drop your bars. One's a negative 9. And if you haven't done so, pause the video and continue to solve. X equals 3. Subtract 6. X equals negative 15. And we're done with this lesson.